So we looked at imines, forming them and then hydrolyzing them. Now let's look at enamines. I want to look at this mechanism. This is the enamine formation from a carbonyl. So you might not be able to visualize that answer yet, but you want to get to the point where you can. But in order to do that, I think it's valuable to learn the mechanism first. So let's do that. What's our first step? Well, you're going to want to protonate the carbonyl. We got resonance. Now, what do we have? We can attack right there. This is a lot like the imine formation. It's almost the same thing, except, well, not really, but it's very similar in the beginning stages. So you want to remember your equilibrium arrows. So there we are. Positive charge. The directions in this case would be to use B- as your base as necessary. So let's do that. Pull off a proton. So we needed to pull off the proton first in order, before we protonate this OH, because you don't want to have two positive charges on the molecule at the same time when you're doing these mechanisms. So what I like to say is mess with one thing first, then mess with the other thing. So we did business with this N, we added it, then we pulled a proton off. Now it's time to mess with this thing over here. So let's use it in order to turn it into a good leaving group, because I don't see an OH in the product. So we need to turn it into a good leaving group so that it can leave, right? It's gone now. Now we're one step closer to our product. We have a positive charge right there. So what does this mean for us? Well, it means we have a resonance form right there. And now what's our last step? Well, it's kind of tough to see. But what actually happens is, this is something you just might want to remember. You've got a hydrogen right here. This base can pull off a hydrogen. Their bond makes a bond right to there, and this bond brings its electrons up. So therefore you end up with your product. And a lot of students may be asking, could we have used this resonance form? Of course. Let's show how that works. So you've got a proton right there. You've got B-, which he gives you in the instructions, and that's it right there. You can use either one. Same product. And that is the enamine formation from a carbonyl. So now let's look at some enamine problems in the GSS number 8. So like I said, it's very important to be able to do the mechanism, but it actually is equally important to be able to just see these answers. Because on the reaction section, you're not going to have time to work out all these mechanisms. You're going to just need to be able to see them. So let's start with number 2. We've got a Swerin oxidation. This is where our enamine comes in. We have an Et2NH. I like to draw it like this. Now you want to envision what happens here. So it might be easy to know the mechanism and then just memorize the product, because you're going to need to go both ways. So the way you do it is, you see where the carbonyl is, double bond, then a line, then the N. I'm going to get to step 3 and 4 later. I'm going to stop right here, and I'll do the rest of this problem in another video. So that's the enamine. So we can look at number 4. So we have Gen Z. It's going to do that to us. So we have this, and then what we do is this. Got a double bond, a line, then the N, and then draw whatever was on it. You'll come up with your own ways of doing it, but the more important thing is to be able to understand the mechanism and then be able to memorize the reactions too, because they're equally important. So let's look at number 12. There it is, 2 groups, simple as that. Now here's a little complexity, number 13. We've got a methyl group here. Now we've got an N with 2 groups on it, methyl groups. We have this basic structure, put a double bond there, or we can actually put the double bond on the other side too. Work through the mechanism to see how we have a choice here. The same story with number 14. When we go to form that double bond, we can either put it there or there. So we must show both products, because Dr. MS likes to show both. So that's the enamine, when you have an asymmetric ketone. So it's pretty cool. How about when you have an aldehyde? Well, it's the same story basically. You've only got one place where you can put your double bond, that's right here. So you go boom, boom, then you have your line, your N, and there you go. So that's pretty neat. That's it for the enamines.